Precalculus, Chapter 1, Section 2. And this is actually going to be part 1 of the notes. In this part of the notes, we're going to go over just a review of transformations of equations. And specifically, we're going to look at what happens with the graph of the equation with these transformations. So when we transform an equation, we introduce a constant value. Right now we're going to call all of these constant values C, but at the end of the notes we're going to give them more specific letter names that you will probably recognize from Algebra 2. So the first transformation we're going to talk about is a vertical translation, which just means the graph shifts up or down. So you can see in your table we have a vertical translation in general function form. So it's y equals some function. It could be absolute value, it could be a quadratic, and then you're just going to add or subtract a value at the end of that function. And then how the graph will shift is that the graph, if you add a value, it will raise the graph by that many units, and if you subtract, it will lower the graph. So let's just use an example, and let's use the absolute value of x. So that's the parent function. So go ahead and graph that on your note sheet. And so notice it goes through the origin and then through the points 1, 1 and negative 1, 1. Now we're going to shift the graph up by just adding values at the end of the function. So we're going to shift it up 3. That means each of the points will shift up 3. So 0, 0 will shift up to 0, 3. And then my points negative 1, I identified 2 other points and I shifted them up 3. Now I'm going to draw that V-shaped graph. And so you can see that the transformation is just the exact same size and shape, but it has shifted up on our XY axis 3. Now let's do a vertical translation where we are shifting down. So we're going to subtract, and let's subtract 5. So that means each point, and I've identified 3 points, I'm going to simply move them down 5. If I were looking at their coordinates, I would subtract 5 from each of the y values. Then you're going to draw your V-shaped graph, and there is the transformation. Let's talk about horizontal translations. So that means the size and shape of the graph doesn't change, but it just shifts left or right. So this is a little counterintuitive. If you look where it says y equals f of x plus c, when you add a value into the x, it's actually going to shift the graph to the left. And if you subtract a value, it will shift the graph to the right. So let's start with a quadratic, and this is just the parent quadratic function, y equals x squared. So graph that on your note sheet. We have the point 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. And so what we're going to do is a horizontal translation to the left. So we're going to add values. You need to open a parentheses so that these values get added right into the input, to the x. Then you close and then put the squared. So this is going to shift each of the points that we've identified 6 units to the left. So I have plotted those, and now I'm going to draw my parabola, my U-shaped graph. So now let's do a translation to the right. So to shift a graph to the right with the equation, we need to subtract a value just into the x, or by the input. So I'm going to shift this graph 7 to the right. So each of the points that I have identified, I'm going to move 7 over to the right, and then I'm going to draw that U shape. All right, so that's a review on translating horizontally. So now let's review reflecting. So we can reflect about the x-axis or the y-axis. So let's start with another quadratic, and now this one you might recognize as being shifted 5 to the right. We are going to reflect it about the x-axis. So notice it says we're going to reflect each of those points across the x-axis. What I would do through the equation is I would multiply the entire function by negative 1. So my negative will sit out front of my quantity x minus 5 squared. And now each of these points will be reflected. So that means each of the y values will become negative. Now when we reflect about the x-axis, if you look at the general function, it's y equals f of negative x. So in this case, we start with our same original function, and then we multiply just the x by a negative. Now, before I graph that, I'm going to do a little cleaning up. So the first thing I'm going to do in the parentheses is I'm going to factor out a negative 1. And so now I have negative 1 squared, which is just 1, and then the quantity x plus 5 squared. So now you can see what I'm actually graphing is x plus 5. So that's going to look like a shift of 5 to the left from the parent function. And now you can see, looking at the graph, that the purple graph is being reflected about the y-axis from that black graph, our original. All right, so that's just a review of y-axis and x-axis reflections. Now let's talk about vertical stretches and vertical shrinks. Vertical stretch and shrinks have a y-axis orientation. So a vertical stretch stretches the graph towards the y-axis, and a vertical shrink will shrink it away from the y-axis. So let's start with the absolute value of x minus 1. So graph that on your note sheet. So that's just the parent absolute value that's been shifted down 1. Now what we need to do is, if we're going to stretch it, we need to multiply by a number that's greater than 1. And we multiply the entire output, the entire function. Just going to make this right. So what we end up graphing is 2 times the absolute value of negative 2. So that's a graph that's been shifted down 2, and then my V shape will stretch up towards the y-axis. So rather than going over 1 and up 1, I go over 1 and up 2. Now with a vertical shrink, we're going to multiply each of the y coordinate by a number that is less than. So I'm just starting with the graph y equals negative absolute value of x. So go ahead and graph that. And then we're going to do a vertical shrink by 1/2. So I multiply the function by 1/2. I don't multiply inside, just outside of that absolute value. Now I have identified 3 points on my original function. -1, -1, 0, 0, 1, -1. And so to do this vertical shrink, I need to multiply each y coordinate by that 1/2. So I get new coordinates of 0, 0, 1, -1/2, and -1, -1/2. When we graph that, you can see that the graph appears wider, and that if you think of it, that the arms of the graph are shrinking away from the y-axis. Let's talk about a horizontal stretch and shrink. And this has an x-axis orientation. So horizontal stretch stretches the graph towards the x-axis, and a horizontal shrink shrinks it away from the x-axis. So it says y equals f of 1 over c times x. So if you have a horizontal stretch, you have a multiplier that is greater than 1, but when you actually do the math, you end up multiplying by the reciprocal of that number. So let's start with the absolute value of x minus 1. You can graph that again on your graph space. And then we're going to multiply just the input x by 1/2. So see that our stretch is by a value of 2, c equals 2, but then for horizontal, we multiply by the reciprocal of that, so 1/2 times x. So I'm going to identify 3 points on my original graph. So I have -1, 0, 0, -1, and 1, 0. I need to multiply each of my x values by 1/2. Then I'm going to take that new x value and plug it into the equation to see what my y value is. So or rather, what I'm going to do is to take each of the x values and plug it in to my new transformed equation. So I'm going to take -1 and plug it in. So I'll get 1/2 minus 1, or -1/2. And then I can take 0 and plug that into my transformed equation, and I will still get -1, and then if I plug in 1, I will get -1/2. So I'm going to graph that, those 3 points, and you can see that the graph, my new V-shaped graph, is being stretched towards the x-axis. Now, with the horizontal shrink, I'm going to start with that negative absolute value of x, and my shrink factor will be 1/2, so that means I'm going to multiply each of my x values by 2. First, I'm going to go ahead and graph that original equation and identify 3 points. And then here's my transformed equation. So now I'll start by plugging in those same x values, so -1, but this time I get -2 with my transformed equation. 0, 0, and then 1, -2. So now when I graph these, we can see that our new transformed V-shaped graph is being shrunk away from the x-axis. All right, so here's something to remember. So a function that involves more than one transformation can be graphed by doing the transformations in this following order. And we'll cover this later on in chapter 1. So horizontal shifting, stretching or shrinking, reflecting, and vertical shifting. And so here's one way to remember it. So I'm going to write a general function equation and put those values in. Now, instead of using c for each one of them, I have changed the values. And so a is our value where we stretch or shrink. And right now I have it on the outside of the function as if it were a vertical stretch or shrink. And then the h value is our horizontal shifting value, and then our k value is our vertical shifting. So for horizontal shifting, that's our h value, so let's remember that. For stretching or shrinking and reflecting, that's our a value in the equation, our multiplier. And then for our vertical shifting up or down, that's our k value that's added. So a little acronym to help you remember the order is the HACK. So horizontal shifting first, then stretching, shrinking, and reflecting, the a value, and then our vertical shifting, our k value. All right, that concludes just our part 1 review of transformations for our chapter 1, section 2 notes.